In this video lecture, we're going to determine the relationship between NFA and DFA and how to convert NFA to a similar DFA. Okay, so we could say that every DFA is an NFA, but not vice versa. Okay, all DFA there is a corresponding NFA because DFA shows how a string is accepted, same as with NFA. Okay, but NFA is different from DFA. Why? We all know that DFA and an NFA could be represented by the five tuple, the Q, the sigma, QO, the final state, and the delta transition. But DFA have different delta transition compared with the NFA. For the DFA, it will be Q by the alphabet will map to a state, while in NFA, a state by um, um, times or encounter an alphabet will go to a 2Q. Kasi don't forget, in an NFA, we could have multiple paths. So it will be based, the highest possibility in the transition will be go to all other paths from this current state. So that's why we have 2 raised to q as path. And we know that DFA path is just part of NFA. So therefore, we could consider that DFA is a subset of NFA. NFA is bigger compared with the DFA in respect with the path. Okay? So therefore, we could not say that every NFA is part of DFA. But we could convert NFA to a similar DFA. Okay? So how are we going to do that? So let's have this example. So a language set of all strings over 0 and 1 that start with 0. So our alphabet or our sigma is 0, 1. Okay. So start with 0. So we already discussed this in our last video lecture. Okay. So design NFA, accept 0. So it will go to the final state. And then afterwards, we'll just have a loop in B. It will be accepted. Okay. So next, so after determining the NFA, so we're going to draw or we're going to determine the delta function, the transition table. So let's draw. So we have 2 states A, B. We have 2 alphabets, 0, 1. So if A encounters 0, it will go to B. But if it encounters 1, no transition, okay, no movement, nowhere to go. So it could be represented by a dash or by a phi sign. And while in B, either value 0 and 1 will just go to B. Okay? So again, this sign means nowhere to go. And in DFA, it could be represented by dead state. Okay? So after knowing this table, now we're going to draw or we're going to convert this NFA to DFA. Okay? So from table of NFA, now create the table of DFA. So in DFA, all values should have a path. Okay, don't forget that. So A encounters 0, it will go to B. But in case we have 1, so in NFA, there's no transition, but in DFA, there should be. Meron dapat. Okay? So since kulang ng state where to go to, we can introduce a new state. So we call it C. and this will be the dead state. Okay, so when A encounters 1, it will go to C. And for B, when it encounters both 0 and 1, it will just go to itself. And since we have a new state, it should have a transition for 0 and 1, should have path for 0 and 1. So if it's 0 and 1, since we are on the dead state or a trap state, it will just loop within itself. Okay, so this is our DFA transition table. So based on this, now we could create or design the automaton. So same with the NFA, A will be the initial state. And then after encountering 0, it will go to a final state, which is B. And in B, it will just loop within itself if it encounters 0 or 1. And if in A state, if it's 1, it will go to C. And any value at C will just loop within itself. So, is this a DFA? Yes. It has all paths for all values. Okay. And only one path for a value for an alphabet. Okay. So this is the equivalent DFA of this automaton. Okay. So let's continue our discussion on the next feature lecture. Thank you.